Hello, hello, good afternoon. Myself, Tanmay Ghosh, and today we will learn about how to install our Scilab. So when you go to the Scilab search in your browser, this site you will go, download this from here. Now, this is a Windows version, Linux version, macOS version, all are present according to your choice. You will download 64-bit or 32-bit. And this Scilab is a very powerful machine, and all the practicals in your course can be done with this Scilab. There is no problem doing your practicals. So you don't have to buy the MATLAB or MATLAB, this costly proprietary software. Scilab is completely free and you can do all kinds of jobs. So this is the latest version, 6.1.1 version, and this who are using Linux, they download this and enter it. You see the process from internet is very easy. So here I am opening my Scilab. Okay, my version is a little bit older. It is 5.5.2. These pins and all this will not show in your interface. Okay, I have downloaded some tools. You don't have to know about it. So how to increase the font size? So here is the increase the font size. Here you can increase the font. Actually, it is in 12 or 13 font size, but I changed it. Otherwise, it will be hard for you to watch. So this is first console, and also you can custom your this sign notes. What is sign notes? I will tell you afterwards. Okay. You can observe it's changing continuously. Fine. Now, first command we use is CLC. It is clear the screen. Okay. Now this one is my global variable. Okay. It will not appear in your interface. Okay. Now, there will be, when you save anything, any variable, it will appear in this box. This is a variable browser. Bottom of it, you can see the command history. Whatever command I used, which date I used, which time I used, everything is registered here. And left hand side is what document directory you are working. That is shown. Now simple arithmetic processes. 1 plus 2 is equal to 3. So I am doing some of these processes. So answer, so 3 is saved as an answer. So I can write answer plus 1 is equal to 4. Okay. I presume that this is the first time you are using Scilab. So you have to know all this kind of arithmetic operations before you jump into your practicals. So a is equal to 2.03. I put the variable a is equal to 2.03 as a variable. Now it is saved here. Top right hand corner you can see it is saved. Now a plus 2 is equal to added 2. Okay. Now when I say CLC, answer is gone, but A is there. Answer is gone, there is no answer, but A is still present. Now 2 plus 1, this is no answer. Now if I type answer, it will give 3. So after I type CLC, the answer variable is gone. But the A, which I fixed it, which I announced that A is equal to 2 2.03, it is present. Okay. CLC will not work to remove the variable a value. Okay. Oh, sorry. I misplaced that. This is how to write comment. Okay. This symbol. So symbol used for comment. Okay. Others it will take as a command. I often use the CLCM clear. Okay. So my screen remains very clean. So I clean the data of A. There is no data set. Now, if I put A plus 3, it will show error. At first, I have to put the value of A. So I put the value A is equal to 3 now. B is equal to 2, C is equal to A plus B. There is 5, simple arithmetic. Now, B is equal to minus 0. So B is equal to 0 minus 0.1. Now C is equal to A plus B is equal to 2.9. Next, is our other operations. Division 4 by 2 is equal to 2, and this 2 into 8 is equal to 16. So all these calculations, they follow the rule, but must follow the rule, but must. At first it is bracket, then division, then multiplication, then addition, okay, then subtraction. This same rule they follow. So let me give you one example of it. So A is equal to 2, B is equal to 3, C is equal to 4, D is equal to 5. Now I write A plus B, A plus B divided by C plus D. Okay, what will be the result? Think about it. $6.25. How it calculated? First A plus B. Now first I have A plus B. Okay. It is saved as an answer. So I am writing answer divided by C. Then 1.25 is my answer. Now answer plus D. Equal result. Okay, it always follows. So keep it in mind. If practice it, it is very easy to remember. If you practice, you can easily do this kind of calculations. Now next, matrix also, sign also will do. Okay. Scilab is a free alternative to MATLAB. And what is the full form of MATLAB? MATLAB stands for Matrix Laboratory. Okay. So this Scilab and MATLAB both are very good in handling matrix, and they represent, a very good amount of matrix representation can be possible. Any kind of matrix representation is very much easy in this kind of softwares. So here A is equal to, say, how we can write a row matrix. So this is a row matrix. One row, 4 columns. A is a row matrix. How we can write a column matrix? So A, you see, within the box bracket I write 1 space 2 space 3. And now here I am writing 5 semicolon 6 semicolon 7 semicolon 8. This is my column matrix. 1 column, 4 row. Okay. If I want to write anything having 3 column 2 rows or 2 column 3 rows, we also can write it. Okay, how we can write that? So C 1. So instead of space, we can write comma also. So 1, 2, 3 is in same row. Then semicolon. That means different next row. 4, 5, 6. Okay. 1, 2, 3, 4, 5, 6. There are many ways to write down matrix. So for your practical purpose, we will learn slowly one after another, but your practical purpose, this much is enough. With this, you can write almost every type of matrix. Okay, and slowly we will. So what is this? Is A prime and B prime. This is transpose. See, B is equal to 5, 6, 7, 8 is a column matrix, and it becomes a row matrix with B prime. Okay, this is very important operation. Please try to remember. Now inverse. Now C cannot be inversed, because whenever you do any inversion of matrix, you need square matrix. So I am writing a square matrix, that is 22 matrix. This is say 1, 2, 3, 4. I am taking very simple examples. In your home, you can try many examples from your book and try it to find out inverse, transpose, whatever you want. So this is D, and now I am doing the inverse of D. It's 2 by 2 matrix. Inverse of D, it will give you inverse of D matrix. Now I can have transpose of D. D prime is transpose, and I also can write inverse of D transpose. Only you see, this 1 and 1.5, they exchanged each other's position in the inverse transpose. You can see that. Here you can see that. Okay. Now A star B. Okay. A is row, B is column, so A star B gives you matrix multiplication. But when I do this A star B transpose, it is not, it will not give you any value because that is not possible. Both are row matrix. So first one row must be equal to the column. Okay, if it has two rows, the second matrix must have two columns. So you have to remember these small things when you are doing any kind of calculation. Now this is element wise operation. So A dot star B, not A star B. Star is for, now when I write A star B, that is matrix multiplication. But when I am writing A dot star B, that is element wise. So A dot star B is not possible, but A dot star B prime possible. What is that mean? See, A and B will be a transpose vector. So 1 into 5, 5, 2 into 6, 12, 3 into 7, 21, and 4 into 8, 32. Okay, this is the element wise operation. Both must be in same order. So both are must be column matrix or row matrix like this. But this is our matrix multiplication. A star B is matrix multiplication. A dot star is element wise multiplication. Okay, this is not possible because both are row. Okay. Now, element wise if you do, there is possible. That is possible. Please see the difference. Remember this difference. Be very careful when you are doing that. Which one you want to use? You want a matrix multiplication or element wise operation? I give you some examples also with division. So A by B is not possible. Okay, but this is possible. Okay, element wise division of B transpose. Okay. So A and B transpose have equal number of columns. So that's why it is possible. Now next we will see okay, linear space. I am taking a range of values. So I am taking from minus to pi, percentage pi. Okay, let me write that why I am giving percentage. Let me discuss about this matter. So when I am writing pi, it will show undefined variable. But percentage pi, if you enter it, it will give you the value of pi. Similarly, E doesn't have any value, but percentage E value 2.718 standard. These are the fixed values. Okay. There is other fixed values are there. The complex number will see about it. So this is I am taking a range from minus 2 pi to pi, 2 pi, and taking about 10 points in between them. So from minus 2 pi 2 pi, I am taking 10 points. So there will be like a 10 in one row matrix will be there formed, and that will have 10 columns. Okay. Can I increase the size? No. Okay, I am trying to increase the size of you can see more clearly. Okay, fine. Clear the screen. The next now how we can do this thing following the previous is just tapping up key and bottom key, arrow key. Okay. Now I have the x values, 10 x values are there, and if I put sin x, it will immediately give you that sin x values of all those 10 values, 10 points. When it is d minus 16, that means 10 to the power minus 16 is a very small number, it is taken as 0. Because the pi value, it is not given all these numbers, points are not given. It is given up to some extent. So that's why this is why we have 8 up to decimal numbers. Okay, that's why we don't have the perfectly 0 value. If you put the perfect value of pi, obviously sin minus 2 pi will become the 0. Now how to plot it? First time, x and sin x, I am plotting dash sign for the solid line and R for the dead correct color. Okay, let's only draw without anything parenthesis. So this blue color is not told by you, it is automatically taken by your system, and these are 10 points. Let me show you the 10 points here. Now here I am trying to show the points as dot. So each point will be dotted and they will be red in color. You can see the 10 point. Okay, this one fault. See these 10 red points because they have taken only 10 points. Now see, I can see anything from previous memory. Any previous command I can see. Go up arrow key, if I press up arrow key, it will show me this all previous values. So there is 100, I am taking 100 values, 100 points in between pi to pi. Now I am drawing the same curve with a blue line, blue solid line. Now see the problem. Yes. Previously it is drawn in blue color. Now it is also drawn in blue color. And what is the problem is you cannot differentiate in between them. This one plot is plotted over another plot. What happened? So every time when you try to plot a new, in the command you give Scilab and open and close parenthesis. Immediately your graphic window will become completely blank. Now you plot anything over it, it will show you perfectly your graph. this sine any value. If I put pi by 2, this is equal to 1. Then now most of the time we write in degree, but the result in degree will give you wrong result. If you put 90 instead of pi by 2, it will give you completely wrong result. So when you only know the degree value, type sin d, d for degree, see, SIND. Instead of SIN, you type SIND. The sin, this is taken only the degree value. You can take only the degree. I am showing you that how it operates, but in your home you do practice. I understand that some of you are just first time learning, that's why I am showing you extensively. Before starting, you need, start with practical, you need some confidence to build up. Be careful about radian and degree. Because sometimes it happens that we write down the degree value. Computer don't understand these things. And let's see some other trigonometrical functions for us. Okay, now let's draw our first curve over it. I'm not cleaning up my screen, so these two plots can be overlapped. And I make it in red, magenta color. So A for magenta, R for red, B for blue, M for magenta, K for black. We will know slowly, one by one after another. Now only first curve. This is the first curve. Now different kind of plots I am showing you. X square. Is it possible to plot? Now I am asking you, this means x to the power 2. I mean x square. So see here, it is not possible. You have to write vector x is taken as a, you say, no, sir, this is why it is vector. Now in this matrix, x is here a range, it is a matrix, it's a row matrix, and every element is taken as a vector in a matrix. Now the formula is correct, you see. 3 square is equal to 9. But when, so these are taken as, so we have to write x dot PLF. Now instead of that, we do that value y is equal to x square, and now I put the value of y and enter it. Now the value can be plotted properly. Okay, I will explain you. So this is one method. If you can recall that where I have to do dot star or something like this. So here, in this case, if you use under the plot command, so x dot hat 2, and previously it is magenta, now I am doing it red, and you see both are same plots. Now you can use that x dot hat 2 as in vector into scalar, to the first scalar, or you can put y is equal to x star star 2, y is equal to x star star 2, and then plot x and y. Any one of the method you can follow. But I generally will suggest you that you put y is equal to x to the power 2 and then plot x and y. Either you use y is equal to x to the power 2, or in the plot command you write x dot hat 2. Whichever is your liking in this case. My suggestion is always put y is equal to x to the power something and then apply it in your plot. That is the best way to do. Now we'll go to our which operations. Let me y equals to exponential. This is for the exponential value. This is the exponential value. And I want to plot exponential value. X y is equal to exponential value is taken. So if I plot it, it will look like this is the exponential value, exponential curve. Now y is equal to absolute of x. So I am taking the absolute value of x. So how the plot looks like? Absolute value here is the absolute value. All the positive value will be taken. There will be no negative values. Now every time use Scilab to clean your and clear CLC, this command. Always use them. Sine degree 90 is equal to 1. We know that. So what is because I inverse 1? 90 degree. it is command is a sine 1. This is given in radian. We can convert it to degree very easily, and we know that 180 degree is equal to pi radian. Pi radian is equal to 180 degree. So answer into 180 upon pi will be 90. Okay, very good. Now same thing can be done with cos. Cos inverse will be a cos, tan inverse will be a tan. Now 4 square is equal to 16. Square root of 16 is 4. Command is sqrt. Okay. Next, absolute square root log of 2. That means log base e. Log base e. Log percentage e is equal to 1. Log base 10 is log 10 on 1000 is equal to 3. Hyper see. Now x already is there, about 100 values. The maximum of x is equal to this, which is 2 pi value, 2 into pi, Now minimum of this range is minus 2 pi. Min is minus 2 pi. So, in practicing at home, install this and you will understand that how to use it. Ceiling. So, you see here that this command is in MATLAB, but there are some differences with MATLAB. So, sometimes you will face this kind of problem. Then don't worry, there is one option called help browser. You can always go to the help browser and search. Here is the help browser. Okay. So this is my help browser open. Just click on that question mark on the toolbar and you will have it. So find here ceiling function. So option is CEIL, CEIL. Here I have the ceiling. This is not the greatest integer value. But the greatest integer value, let me plot this one, show you the plot. It will look like a step. Same. See, it will look like a footstep. Stairs, right? It look like stairs. Now next is our the discrete line. Let me show the discrete line. This ceiling function here. They can be discrete. Now the greatest integer is our floor. For the greatest integer, the command is floor. That is box x. This is box x. Let us draw box x. Okay, do floor x. Enter. Here. Similar kind. Now next is our sine hyperbolic. That is sine h. Sine hyperbolic is sine h. Cos hyperbolic is cos h. Tan hyperbolic, tan h. Similar to tan hyperbolic, tan h. Now tan hyperbolic inverse, sine hyperbolic inverse. This kind of problem we write a tan h. A tan h. And this is the kind of plot we have. Okay. Now, complex number, another problem. So, we know for the complex, we have this a is equal to some number, b is equal to some number, so z is the complex number is given by a plus ib. So z is a plus ib. A is equal to 2, b is equal to 3, and then the complex z is equal to a plus ib. If you write it like this, it will show an error. Let me show you. It will show that ib is not a variable, undefined variable. Yes. I have to write percentage I into b, percentage I into b. Then it will show you that this one is a complex number. I will be taken as a complex. Okay. This one is also like your predefined, like pi and exponential. Clear the screen? No. If you presume I put x is equal to in this is another style. With except namespace, we can write it like this also, minus 2 pi. Okay. Then the step size, the initial value, then the step size. The step size, let it be small, just 0.1, and up to 2. Okay. In this manner, sometimes the last value is not taken in care. How is it happen? Let me give you other smaller examples so it is easily understandable. So I start from 0 to 10 and this is one gap. How many points will be there? 11 points. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I put it 0.5. How many points will be there? 21. Yes, 21. 0, then 0.5, then 1, then 1.5, then 2, then 2.5. Up to 10. In this case, if I put not 0.5, I put it at 0.7, then the last digit will not be present. In that case. And step size. If you change the step size. Now y equal to lean space 0, 10, and I am having 21. The result will remain same. X will be equal to same result. So in either way, you can write whichever is appropriate for the problem, you have to use accordingly. So be very careful about it. Thank you very much. See you in next class.